While the clip models we found are downloading, we need next to get a SDXL based model. I will use the website Civet AI to find something more interesting than the base model. To work Civet AI, you want to register and log in. It is worth it if you're going to do any stable diffusion and need models, low range adaptation, or checkpoints, or any model. They also have resources. They let you generate images if you pay. That is how they profit. We are doing this on our own and avoiding that because we are going to pay upfront for hardware to run it. So it's a trade off. If you want to run it yourself, you get hardware. If you want to just run things on a easier level, you can just use Civet AI or OpenArt or whatever site you want to use to generate things. To work the user interface, click Filters on the top right of the Models page you select here on the left next to Home. Select the time range you want to search for, the model type checkpoint. If you're looking for a main stable diffusion model, you want the checkpoint usually. We're going to look for merge models today to find something more advanced and interesting. And I have one picked out that I know is the best. Depending on what you're trying to accomplish, what style of art, we have selected the Safe Tensors file format SDXL 1.0 for today, with merge models selected once again. And you can see there are many models that are merges. This Tamarind XL looks like it's cool. I don't know anything about it, but there are others that are NSFW, not safe for work, or are safe for work more so, as just SDXL base is more sterilized. Custom models being merged together into one big aggregate model is going to give you more NSFW data sets incorporated into the single model without any low range adaptation models or anything. You have more types of input artwork that it was trained on, so it will produce a wider range of styles in the end. Either illustration up to hyper realistic that looks better than a photograph, in my experience. So we want Albedo Base XL. You can choose a different model, download the model. I have the model downloaded. What you want to do is go to your ComfyUI directory and the models directory, in the checkpoints directory. Make your own SDXL directory within it to organize, and put the Albedo Base XL Safe Tensors file or your SDXL model of choice file into this directory, which also has the clip models directory filled with our clip models that we've placed here. Clip L and clip G will be used today. We are assuming that you have Comfy running as per my previous videos, accomplishing that for us on an Ubuntu Studio system today. If you need a workflow, you can find, for instance, the ComfyUI examples listing this is a good page because it provides workflows for all these different technologies, probably over 20 choices of technologies: unclip, flux, SDXL we are using today. So you can drag and drop the image for a workflow. And I'm dragging and dropping onto this panel in Vivaldi. I have done videos on Vivaldi, and I like to use the panel. It's unique to this, with this implementation that I like in particular. With Albedo Base XL, it says the refiner is unnecessary because it has such capability with the base model. You don't need the refiner, as said by the developer of that merge model, which he seems very experienced with this. So we want to start making a model from scratch. This is what it looks like half through. I started doing it, screwed up, have to re-record this entire part. I don't mind for you guys. And I could just show you a finished workflow like this one, but that doesn't let us dissect one step at a time from scratch and see the inner workings. And when you're done, you'll have a greater understanding than when you started of Comfy and stable diffusion every time. And you have to practice and do it again and again to progress your skills, learn, progress again and again to get anywhere. And I've been working at this for some months now. I was a little late to the AI game, and I've only been at this for less than a year. And I had a lot of late nights. I have trained models for lower range adaptation, LoRa models myself, released on Civet, and I have experimented with all different model types and workflows, control nets, and I already have videos demonstrating a lot of this, just the basics that we can later expand and integrate together into one huge Frankenstein workflow. The first node that we want to place, we know, is load checkpoint. It will help us think by seeing the required input and output for each node. Just place some nodes, and it will help you think by seeing what they take in and out, doing things one step at a time. This video is really for beginners or those looking for some optimizations to the basic workflows, incorporating things like a resolution calculator that will supply the empty latent image with the right resolution. And I use SDXL specific prompt and conditioning box. The clip text and code SDXL node, which we'll place right now after two of them, one for positive, one for negative, and I set the color for organization. And these take the clip that we will supply it with, and we will not use a baked clip. We will use the dual clip loader node and select the model clip L and clip G that we just downloaded in the previous steps, which are supplied to each clip text and code SDXL node here. When we do the resolution calculator, I like to also do basically the same thing converting these widget width and height to input on the node using a resolution calculator node. There are multiple available in the community. I use JPS nodes, SDX resolutions, JPS. That's why we got the JPS node from the custom nodes manager. I don't know if you saw the part or if I lost the part today showing the custom node. So I'm going to just show you one last time to be sure which nodes I have. And we want to have WAS node suite, JPS custom nodes, in the efficiency nodes packs, which you can find easily in the model manager. Download, restart Comfy, and we will have what we need to make a good basic workflow that's not too boring and basic either. You'll have better images this way, especially with this calculator for the resolution. It supplies the proper number of pixels, 1024 by 1024 number of pixels, with each dimension of the resolution also being divisible by 64. Those are the requirements. Both must be satisfied. And underneath that, we want to have a standard, like a square, 4:3, or particularly 9:16, 16:9, etc. A standard ratio is ideal. So you can use this calculator to achieve that with a button press. We use the empty latent image, which is going to be given to the case sampler we place in a moment. We are setting up the empty latent image resolution calculation mechanism. Right click the empty latent image node, convert widget to input, convert width to input, and convert height to input. You can see it's now on the left with these width and height. Hook up the resolution calculator from JPS, and we are good to go there. But I also have been not leaving these at 1024 on the text encode. I figure it's a feature of this. It's going to provide additional information compared to the standard text encoder regarding what width and height we want their encoding to end up providing us with in the end. So I am going to convert all of these relevant widgets to inputs and supply the same resolution from the calculator as I did to the empty latent image. So they match up in the end. Nothing will be cut off this way. I have done this and achieved good results with my images, so I'm doing it again here. I do the width, height, and target width and target height widgets. I leave crop width, crop height at 0. Do the same thing on this node. And when you're done, hook up the resolution calculator node to the corresponding inputs we just created. And with this node, you can supply separate text L and separate text G for both positive and negative using my workflow with the proper pixels automatically given to everything. Width, height, or width and target width, height, target height, and then the same thing to the negative, width, target width, height, target height. And this is making sure everything corresponds, or you're going to have distortions and clipping. Things will be cropped off, and it's not the model's fault. It's a flaw in the typical workflows that I've seen, that they're not doing all of this. So we have the conditioning ready. We want to make sure we remember to give it a prompt first before we run it. But next, we know we can place a K-sampler node, and you will use load checkpoint to hook up some inputs on that. And I have used the efficiency nodes pack for this most commonly. K-sampler efficient node. This will let you use a decimal for the denoising. Let's see what we can do with this sampler. Let's do a two-sampler, two-stage sampling to show you the daisy chaining and how to hook that up properly. You can use one sampler, put the denoise of approximately 1.0 to fully denoise. First, we can hook up this checkpoint model, use a reroute when possible to help organize later and make your workflow clean. We're using the dual clip loader into this. So we want to give the positive and negative conditioning to the K sampler and hook up our latent image that is properly being supplied with the width and height from the calculator from JPS or your calculator of choice. If you want to experiment, feel free. Just make sure it has the proper resolutions as I explained already. And we will give the VAE baked, we assume properly from Albedo BaseXL today. If you have artifacts in the image, green lines or something that are present, you might need to change the VAE to an SDXL 0.9 version VAE. If it's using the 1.0 version, it's known to provide a subpar experience with artifacts. Hook up the daisy chaining to the second K sampler. This VAE input lets the internal decoding occur for the VAE to and from a image in a latent with it, and it's integrated with the K sampler if you use the efficiency nodes. If you supply the optional VAE, you can use this image output directly. Otherwise, you need to use a VAE decode node separately, hooking up the VAE, inputting the samples from the latent output of the sampler. It's equivalent. This is integrated, so I use this node for the daisy chaining. That aspect of the VAE decoding, you can set it to tiled VAE true. have the image out into the preview image node, as well as a save image node. There are multiple save images nodes, and I use image save from WAS Suite. That's why we install that today. Image output into the save, into the preview. Just to set that up real quick before we look at the K-sampler settings.